Welcome. Let's discuss how we can solve rational inequalities. Let's start by understanding what we're looking for. On the left hand side of the inequality, here we have a rational. And what we would like to think about is what values of x will make the whole fraction less than the value of 0. Well, we have a strategy to find those values of x's. The first thing that we're going to do is to make sure that one side of the inequality it is equivalent to 0, which we have it. Next, what we're going to do, we're going to set the numerator equals to 0 and also the denominator equals to 0. So we're going to get x minus 7 is equivalent to 0 and also x minus 1 is equivalent to 0. And then we're going to solve individually. So on my numerator, let's add 7 to it. And now we got a value of x equals 7. And on the denominator, let's add a 1 to it. And that's going to give me a value of 1. These are not the solutions of this inequality, but we're going to use these values to identify the solutions. Because now we're going to create a number line using the values that we got when we set the numerator and denominator equals to 0. So let's visualize that. So here we have our number line. Now let's estimate where they are. X equals 1, and let's say that it's somewhere around here. X equals 7, in a number line, it should just be on the right-hand side of 1. So let's just say that it's somewhere around here. Notice what we have done. When we place those values, we have cut down the number line into 3 intervals from negative infinity to positive 1. Let's call this interval 1. From 1 to positive 7, let's call this interval 2. And from 7 to positive infinity, let's call this interval number 3. And now the last thing that we want to do, we're going to be testing those intervals. Let's do it one at a time. Under interval number 1, let's choose any number that is less than positive 1. I'm going to be choosing 0. 0 is definitely less than 1. And the way that we're going to be testing this interval, let's get this value that is in the interval and let's substitute it on the inequality that we were given. So on the numerator, we're going to get 0 minus 7. And on the denominator, we're going to get 0 minus 1. Let's simplify that. Here we're going to get negative 7 divided by negative 1, which is just positive 7. Once we have a value, then we're going to ask ourselves one question. Is this true? Is 7 less than 0? So this is definitely false. And because this is false, then all those values which are less than 1, which is interval number 1, cannot be considered solutions of the rational inequality that we were given. And now let's repeat the same process, but for the interval number 2. Let's choose one value that is between 1 and positive 7. I'm going to choose the value of 2. And let me test that number. Let me plug it in to the rational that we were given, and let's try to see if the result is less than 0. So we're going to get 2 minus 7 on the numerator and 2 minus 1 on the denominator. Let's simplify it. Then we're going to get negative 5 divided by positive 1, which is equivalent to negative 5. And now let's ask ourselves one question. Is the result that we obtain, is that result less than 0? Well, that's definitely true. And because we obtain a true result, then we can say that any number that we choose between positive 1 and positive 7, which is our second interval, will be considered a solution of this inequality. So now let's move to the last interval, the interval of those values which are greater than 7. Let's choose any number that is in this interval, any number that is greater than 7. I'm going to choose 10. And let's plug it in to the rational that we were given, and let's try to see if we obtain a result that is less than 0. So on the numerator, we're going to get 10 minus 7. And on the denominator, we're going to get 10 minus 1. So here we're going to get 3 divided by 9, which is essentially 1/3. But notice that the value of 1/3, it is definitely not less than 0. So this is false. And because we obtain a false statement, then we know that any value that is greater than 7 will not be considered as part of my solutions. So now we can identify the solutions for this inequality. We're only going to consider that interval where we had true statements. So the solutions are going to be located at the interval from 1 to 7. Well, now we gotta test endpoints. Well, ask yourself, if we plug in exactly the value of 1, is that okay? You notice that it's not, because when we plug it into the denominator, we get 0. That's undefined, so we cannot consider that as part of my solution. So now let's represent that with a hole in the inequality and with a curvature bracket in my solutions. And now let's take a look at the other endpoint, the value of 7. Is it okay for us to use the value of 7? But notice that when we plug it into the numerator, here we're going to get 0 divided by 6, which is 0. But notice that we were just looking for those values that were exactly less than 0, not equivalent. So because here we got a false statement, then we cannot consider the value of 7 as part of my solution, and we're going to also represent it with an open parenthesis. So we are done. Choose any value between 1 and 7, and we're always going to get a true statement. Now let's visualize that in a graph. Here in the bottom right hand side, this is the graph that we would have obtained if we graph the function of x minus 7 divided by x minus 1. Here we can visualize our result because we are intersecting the x-axis at the value of x equals 7, and we also have a vertical asymptote at the x value of positive 1, and notice that it is only at this section where our y values are less than 0, which is exactly what we wanted to find. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.